In this module, we'll see about working with data in Python using Pandas. Why Pandas? We have Python, but why we specifically use Pandas? Why we need to download this and why we need to use this? We'll see that. So while handling big data in data science, so data science is like collection of data, and we are using that to do some progressive outcome, right? So Pandas allows us to analyze those data and make conclusions based on statistical theories. So it can clean the data and make them readable and relevant. So it is very important in data science. So as a part of data science, we'll be seeing machine learning, right? So in machine learning, what we'll do is we'll give the data to the machine for it to learn. So based on the past data, it will predict and give us the future. Okay. So based on the past experience, it will do prediction. So any improper value or unwanted data, if it is present, then it may lead to improper predictions. Any single value can even affect our prediction result. So that's why it is very important to have relevant and proper data. And most of the time, all the available data set may or may not be correct. So we have to check it. We have to also analyze the data. We have to make conclusions. So for that, we are using this Pandas library. So if you are going to use this Pandas, you have to first install it. Okay. So you have to install it in your IDE. If you are using any other IDE other than Google Colab, then what you have to do is you have to go to your terminal and go inside the command prompt and then type this command pip install pandas. So this will install the Pandas library. So if you are using Google Colab like me, I will tell you how to install Pandas, how to install a library. So this pip is a command for Python package installer. Pip Python installing package install pandas. So while using Google Colab, what you have to do is we are going to run this pip install pandas. So this pandas is the library name. There are many other libraries. So if you wish to install, you have to give the name here. Okay. With pip install, you have to pass the name here. You can get the name from the browser. You can find that. So in case if you are installing it in Google Colab, there is no specific command prompt for this. So what you have to do is you have to mention exclamatory bar before this pip. See here, now there is no error, and if I run it, it will start installing. It will download, and since I'm already having this pandas, it is telling requirement already satisfied for me. And if you are newly using it, it will start downloading and it will install. So this is the installation part of library pandas. Next, importing pandas. So we have now installed it in our system or in our IDE. So every time when we need pandas, if you are going to use that tool, you have to call the name of pandas. Okay. So for that, you have installed it, but you have to import that. So importing is nothing but you are making it to use in that particular session in that IDE. So now what I will do is if I am creating a new notebook in Colab and if I need to use pandas, I have to first import all the necessary libraries. I'll start with import pandas. So if I need to use something from pandas, I can call the name pandas. So pandas dot, you will get all the methods and attributes from pandas. You can use that. And see here, as I told you, every time when you need to use pandas, what you have to do is you have to type pandas dot. You have to use it everywhere. So you'll be using this pandas in a very in most of the places we will be using that, and it is little bit time consuming. And for that, what we can do is we can give an alias name. Import pandas as PD. So as PD is a short form name for pandas. You can set any name, but it is a common PD is mentioning pandas. So what you can do is you can type this in your Colab and in your code cell, and you can run this. So this will load pandas in the name PD. So whenever you need to use pandas, you can call the name PD dot. So it will direct it to pandas. Okay. So in case we are writing a bunch of code, this saves a lot of time. So let's import pandas now in Google Colab. Import pandas as PD, right? So I'll run this. So now when I need to use pandas, I can call the name PD dot. So this will give all the methods and attributes present in pandas. Okay. So we'll see that what are the useful tools present in pandas, why we are using it for analyzing the data. So we'll move on into the data analysis topic now. Okay. As I told you earlier, in data science and in machine learning, the first thing we'll do is we'll give the data to the machine. So to give the data, you have to load the data, right? So all these data sets are most commonly available in CSV file format. Okay, instead if you are not using any databases, you can directly get your data from databases. But at the starting level, you will be using some data sets which are commonly available in internet. There are websites such as Kaggle and Google Dataset Search, UCI repository, machine learning repository, from where you can download your datasets. Datasets like, for example, if you are going to solve using data science, using machine learning, if you are going to solve some heart disease prediction or diabetes, what you can do is you can download the past data from browser. Okay, it is already available. So these data you can download it, and these data are commonly available in CSV file format. CSV file format is nothing but comma separated value format. Okay, so CSV file format is comma separated value format. So it is, this file is opened with the help of Excel only. So it is similar to Excel with rows and columns in table format. So you can download it from these websites, and if you want to load it in your code, then what you can do is you can use this pandas to load your CSV file. See here, I am creating a variable known as dataset. Here I am importing pandas, and I am creating a variable known as dataset is equal to pd.read_csv. So from pandas I am using pandas here, and I am using read_csv, and inside the bracket I am passing the name. Okay, so here you have to pass the entire path with the name with extension. So if you are storing it in your desktop, this file data.csv file, you have downloaded it, right? So if it is in downloads, you have to pass the path where you have downloaded it with exact path, and then the name with the extension .csv. Inside quotation you have to give like this. So this will load, this pandas will help us to load the dataset in this variable dataset. So when we need, we can visualize that, and we can use it in further steps with this by calling this variable name. We load our dataset now. If you are using any other IDE, you have to just pass the path of it. And instead, if you are using Collab like me, then you have to upload it here. So what you can do is, as yourself, right, go to the left side, click this files, then right click here, click this upload option. You have to upload it. So locate your file where you are having, and I am having this placement dataset of students. I am going to use that. I'll click open now. So this will load into our cloud. So you can, now we have loaded it, right? So now I can copy the path of this file. Click this three dot, click copy path here. So now we have copied the path. Instead, if you are using any other IDE in your system, you can directly paste the path from where you are storing your CSV file. Okay, now I have to create a variable dataset equal to, so in this page I am using pandas, right? I have to import it only once. So we can use it anywhere, but this is the first time only. You don't want to install it every time. If you run means it will tell requirement already satisfied. But if you are going to use pandas now, you have to import once, and then you are ready to go. I'll call pandas.read_csv. So this will help us to load the dataset. I'll paste it here. Okay, so this is a placement dataset, and I have uploaded it here, and I am copying the path. Okay, I'll run this. So now it ran, right? No error. So this dataset variable now is storing the placement dataset. Let us print that dataset. Okay, let us see what it is there. See here we are having some table, so due to length it is splitting it here. So we are having the student data set with column name, serial number, gender, so where are they from, what is their score in each part of their education, what is their department, okay, their work experience, their specialization, their status, whether they are placed or not, and we are having some salary column here. So totally this data set contains 15 rows and 15 columns. Okay, so I'll tell you how to download a dataset also now. You can go to the website such as Kaggle. You have to create some account there, and from here you can download datasets. There are many datasets available in this website. You can download it. Okay, there are many competitions also going on. I'll search for diabetes dataset. You can search the name here. So this will give many codes. You can click it. Whatever you wish, you can go inside and check about the dataset, and if it is good for you, you can even download it. You need an account to download. Okay, so it is loading. So this dataset contains a column such as pregnancy, glucose, blood pressure, skin thickness of many patients. So many columns is there. Finally, zeros and ones. So 1 means diabetes present and 0 means diabetes absent. So this is a CSV file dataset. You can download it by clicking it here, download. You need an account, okay, to download this. So I can download it and I can open it. See here it is opening in Excel. So like this, the placement dataset we have seen, right? So this is a dataset. You can load this too. There are many rows. So these are the past data which will be giving to the machine. But it is opening in Excel format, right? It is a CSV file. It is opening with the help of Excel app. But to load this in your Collab or in your IDE, we are using Pandas. Okay, I can load this too. I'll show you. I click upload. Okay, diabetes. I'll open it. Okay, it is loaded now. I can copy the path here. Okay, I can paste it inside this. So this is the path where you can store it. I'll run this. Now let us print our data set. And can you see we are having those columns? Pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and the outcome column. 768 rows and 9 columns. Fine. So you can see it in this also. See here. So the same column names, all the columns. This file have been loaded now in the variable dataset. Okay, all those values now we can visualize in our Python IDE. This dataset is storing these values. If I run it simply, it will give us in the table format itself. In Collab, see here we are getting that, right? So in the table format. So this read underscore CSV, what it is doing is it is loading the CSV file and it is converting it into a data frame format. So in Pandas there is something known as data frame, which is nothing but a combination of rows and columns. And with many rows and columns, it is called as data frame. And if it is only a single column, okay, imagine only taking a single column. If it is only one column with many rows, then it is called as a series in the Pandas. It is called as series. And if it is many columns, then what it is called as? It is called as data frame. So this is what this read underscore CSV does. It will load our dataset and convert it into a data frame format. We can do further process with other tools.
You can convert the masterclass into 1 month certified internship on natural language processing. So if you convert the masterclass into a certified internship, you would be getting 30 days of live and recorded sessions, 30 days of PPT for download, 10 project source codes for download, 1 month internship certificate, participation certificate, 90 days of access to courses, 4 hackathon live sessions and community group access as well. So you can avail all these benefits by registering at the link which is posted in chat box. The regular fee will be 1,999 and the discounted fee for a limited time is going to be 799. So if you guys are interested, the registration link is available in chat box. Pinned in description, you can click register and then join and get all the benefits of the internship. Not only that, you can also join for our 4-in-1 bundle course, which includes NLP, this masterclass course, as well as Python programming, machine learning and artificial intelligence courses. So the regular fee for this bundle is 3,000, but the discounted fee is 1,299. The registration link is posted in chat box. It's a limited time offer. So what is the benefit I'll be getting if I join the bundle? You'd be getting 120 days of live and recorded sessions, 120 days of PPTs for download, 10 project source codes for download, 4 internship certificates, 4 separate certificates, 1 year validity to courses, hackathon live sessions, community group assignments and mock tests. You can avail all these benefits of individual internship as well as bundle. So if you guys are interested, the registration link is available in chat box. Please make use of it.
Next we'll be moving on into analyzing the data with the help of Pandas. So we have now loaded with the help of Pandas, right? So now the variable dataset is a data frame of Pandas. We have loaded the dataset in this variable dataset. So this is converted in a data frame format. So there are many functions in this. What you can do is you can call the variable name and click dot head, okay, and with parenthesis, what you can do is you can visualize the first 5 rows only. So whenever if you are loading a new data set and you want to know what is the column names, what are the values present, how it is, whether they are text format or numerical format, what are the things present, if you want to visualize, for just what we can do is you can call dataset, the variable where you have stored your dataset, dot head. So this will return first 5 rows. We'll check this. So I'm having this dataset and it is, see here, it is showing the first 5 and then it is slowly showing the last 5. It cannot show everything, right? So instead what you can do is you can just check the first 5 rows, dataset dot head. I'll run this. See here, we are having these. So first 5 rows, starting index from 0, 1, 2, 3, 4. The first 5 rows have been present. I'll also create dataset 2 where we have loaded previously our placement dataset, right? CSV read underscore CSV. I'll paste this path here. We'll do it parallelly also. I'll run this. So let us visualize the dataset 2. Can we see the first 5 rows? Dot head. So this is the first 5 rows from the dataset 2, which is a placement dataset, and we are having serial number, gender, they are like from where they are, the marks, their degree specialization, their status and their salary details. Okay, this is a placement dataset and this is a diabetes dataset. To see the first 5 rows you can use this dot head, and similarly if you want to visualize the first 10 rows, what you can do is you can pass the value here. Okay, if I need to get 10 rows, I can pass this. So this is like dot head is a function, like we are giving default values in a function, right? So if we don't give a value, it will like print only the first 5 rows, and if we mention some value for some limit, it cannot print. If we mention first 50, it cannot show the first 50. To some extent it will print. Okay, it is loading. So this 10 will give us the first 10 rows. That's how this thing works. So see here, we got the first 10 rows, right, from 0th index till 9th index. So this is the first 10 rows. So you can do this with this also, this dataset also with diabetes dataset. So if I give 15, it will print the first 15 rows. Okay, this is how you can just analyze the data, the first few things. See here, we got the first 15. So you can just get a glimpse, right? So that's what this dot head is. And similarly there is something known as dot tail, which will give us the last 5 rows. Okay, so this will give us the last 5 rows. We'll see this in Google Colab. So let us see about the last 5 rows. So what I can do is I can call the tail dataset dot tail. So if I run this, it will show the last 5. Okay, last 5 rows of this dataset 1 is the diabetes dataset, and I can also go with the dataset 2, which is a placement dataset. So similarly with like head, this tail, you can also pass the values. If you pass that values, it will print that. Okay, from last. Okay, I am getting the last 13 rows. That's how this thing works. Fine, we are getting the last 5 rows, last 13 rows here, right? That's what this head and tail is. And if you want a general information about this dataset, what you can do is you can call this dot info. So this dot info will give us some information, some useful information about the dataset. Let us check this and let us see what we are getting. Okay, so I am going to call the dataset dot info. So this will give us the information. And see here, this belongs to the class Pandas. Okay, it is a data frame, as I told you, and there are totally 768 entries, which is starting from 0 till 767. So there are totally 9 columns, and the column names are this: pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age and outcome. So regarding the non-null values, which means like, or it will give the non-null count. So if it is like 768 null values, there is no null values. Okay, non-null, there it is not a null value, which means actually a value is present there. and it is obviously it is you can see here there is no null values because all the values are 768. It means there is no null values. So if there is a null value present, we cannot give that directly to the machine. We have to handle it, and we'll see that in the later part of the module. And also we are getting the information about the data type which is present. About in each column it is integer 64, then what it is float, and so on. Okay, so this is like memory usage also. This is what the general information about this data set. Okay, that's what this dot info will do. And there is also something known as dot describe. You can see here dot describe. So this will give us a statistical summary. We'll check that with dot describe. I can call the dataset 2.describe. Okay, let's go with that. So wherever there is like numerical values, it will give us some statistical summary using this describe. See here the total count we are having, the index like total count is 215. Okay, in salary column we are having 148, and the mean value, what is the mean value, which is the average value in each column. So what is the average salary, you can see that. What is the average marks, okay, something like that. What is the standard deviation, these values in each column. So what is the minimum value in each column, what is the maximum value, what is 75% of the value, 50%, 25% of those values. You can check that. Okay, so we can call the dataset 2. Let us see about the information also in the placement dataset. And I hope you can see like all the columns having 250 non-null values, and this salary column is having 148 non-null value, which means some values are null values, right? So you can also get the describe statistical summary for the dataset 1, which is a diabetes dataset. Describe. So we will get some statistical summary about what is the total count, what is the mean, like what is the outcome, what is the like minimum and maximum values, and standard deviation, mean values, and so on. So this is what this pandas do. Okay, it will give in very fraction of a second. It is giving out many informations which are very useful for us to decide. So next, let us see some other things also. So to get what all the column names present, you can use this dot columns. So this will give us a list with all the column names. Okay, dataset 2 dot columns. You can store it in another variable also. See here we will be getting a list with all the column names, right? You can go on and check with this dataset also, dot columns, diabetes dataset. I'll run this. Okay, we are having, right? So these column names are given as a list, and you can also find the shape of the dataset. So shape is nothing but how many rows and columns. If you run this dot shape, this will give you a tuple with rows and columns. Okay, first value is mentioning the row and second value mentioning the column. Dataset dot shape. So this will give us a tuple with rows and columns. So there are totally 768 rows and 9 columns. Okay, let's go on with dataset 2 also, shape. Okay, 215 rows and 15 columns. And dot d type. So this d type will give you the data types present in each column. We got that in the information itself, but you can get that separately also. Dataset dot d type. D types. This will give us the information about the data type present in each column. So this column contains integer, this is float, value which is stored in our dataset dot 2 dot date types. Okay, we are having objects, integer, float. Okay, so this is how you can check the data types, and you can also go on and check with what is the index present. For that you can call dot index. So it will give the information about the index. Dataset dot index, and it starts from 0 and 768 is the ending one, and the step is 1, which means like what is the actual step. If it is 2 means it will go from 0 to 468 and so on. Here the step is 1 only, so 1 by 1 the value is increasing, right? So that's what this step means. Okay, and furthermore, let's see about, okay, so before seeing this, let us go and see how to select a single column. Okay, so selecting a single column, for that what you can do is you can call the, what you have to do is you can call the name of the data set where you are storing your data set. So that is obviously data set, and inside square brackets we will be passing some index number, right? So select some particular index, we can get the output, you are passing it inside square brackets, right? So similarly what you can do is you can call the name of the column inside this square bracket with quotation, it will be passed as a string. So this can be selected single column, or instead what you can do is you can like click the data set and you can type dot, and with that you can type the column name. We'll see this how to select a single column. So in this data set I'm having many columns, right? Let me select the glucose column alone. Okay, so for that what I'm going to do is I'm going to call the data set, and inside square bracket, inside quotation, I'm going to type the name of the column glucose. I'll run this. See here it is selecting one single column, right? So it starts from 148, 85, 183. We'll check that. 148, 85, 183, 89. So this column is selected single. Okay, so you can select like this. You can select a single column. Okay, you have to type the name inside this, or instead what you can do is you can call the data set dot glucose. Okay, you can type the name of the column. So this will also fit the data like that single column. See here both are similar results, right? So there are two ways to select a single column, and if you wish to go for multiple columns, instead what I am doing is, see here the name of the columns. So I wish to get this glucose blood pressure or glucose blood pressure skin thickness. So multiple columns, if I need to select and store it in somewhere else, you can actually do that. And how we can do it, we'll see that. To select multiple column, you have to pass it like this. Okay, we are opening the square bracket, right? Give another square bracket and inside multiple column names. Those names will be considered. Okay, and you can select that. And what you can actually do is you can create a new variable name. You can give any name. I'm just giving a new here. New equal to, I'm just passing this inside of it. So which means you can select a single column or multiple column and store that in a new variable so that it will become a separate one. Okay. So if you are selecting multiple columns, then it will be stored as a data frame in Pandas. And if it is a single column, as I told you, it will become a series in Pandas. Okay. So now we'll select a single or multiple column. We'll check that. I can call the data set, and inside square bracket, another square bracket. Let me pass the name of the columns. Glucose. You have to type the name exactly. Okay, we'll get the column names from here, right? Blood pressure, skin thickness. I'll select these two also. I'll pass it here. Let me give similar quotation marks, single quote. Let me run this. See here we are selecting that columns alone, right? So this is a series, it is a single column, so it is like a series, and it is multiple columns, so we are getting the data frame. And this is how you can select single and multiple columns. And going back to this, so if you wish to find what are the unique values present in a series or in a single column, okay, see here we are selecting these columns, right? Let me like go on see my data set again. We'll select it here. We'll do it separately below. Let me call my data set 2. Okay, we'll do with this dot head. Let us visualize our data set first. So this is a placement data set with these columns, and I want to know what are the things present in this column. Okay, status column. We'll check that. Okay, obviously status may be placed and not placed, but I need to know what are the unique values present. Okay. For that, what I can do is I can go with this dot unique. So I need to select that single column and type dot unique. So this will return the unique values present in that single column alone. Okay. So what you can do is I can select a single column. Let me call the data set 2. I need to select a single column. I'm passing it inside quotation, inside square bracket, status column, and I need to get the unique values. So dot unique. Okay, so let us run this and see what is the output. And can you see here we are getting a list with an array with what are the unique values? It is placed or not placed. Two values are unique values. You can go and check with other columns also. Let me go here and select some other columns. What we can do, we can check with this HSEB. Okay, we'll go and check what are the unique values present in this HSEB dot unique. So this will return the unique values which are present in that column. We'll check with HSES also. Okay, some space gap here. The name should be exact. See here, others and central is a two column, two separate unique names present. HSES, right? Let us see the departments: commerce, science, arts, right? So these are the three values which are repeatedly used. Okay, these are the unique values. Similarly, if you wish to know the number of occurrence, okay, how many, there is question, right? So there is a question, how many times this is occurring. Okay, we have seen about the data set here. It is like placed and not placed is there. How many places placed is there and how many not placed is there? If you want to count that, what you can actually do is you can use this dot value underscore counts. This will count the value for you and give you a result, how many unique value, how many number of occurrence it is occurring. Okay, what you can do is you can go on with, I'll copy this. Okay, I just need to change this unique, and instead what I'm going to give is value underscore counts. Okay, I'll run this. See here, we are getting the unique values with the number of occurrences. So place this in 148 value, places 148 rows, and not placed is in 67 rows, which means 148 students are placed and 67 students are not placed. That's the meaning, right? You can check with the dataset, another dataset also, dataset.head. Okay, so we are having these things, everything is a numerical value here, and it may vary, you cannot get the unique values here because every value may be a unique value and you will be ending up with a lot of value. We can go and check this outcome column, what is the outcome and how many yes and how many no, which means how many diabetes present and how many diabetes absent. You can check that. Dataset, inside I can pass the column name dot value underscore counts. So let us check, and this will give in 500, for 500 patients it is diabetes absent and 268 patients diabetes present. That's what the meaning of this, right? So this is how you can analyze the data with the help of Pandas. And what you can do is you can actually get the mean value. Mean value is the average value. You can select a single column and ask for the mean value. It will return the mean value. So you can call the dataset that single column dot mean. This will return the mean value. And if you wish to get the median value is nothing but arranging it in increasing order and then taking the middle value, right? So that's what median value is. You can also get that with the help of dot median. We'll do both of this. So what is the value? You can get the average glucose level, or we'll get that average glucose level. We have to select a single column, glucose, and I am going to get dot mean, which means average value. 120 is the average glucose level in these patients, and if you want to get the middle value, you can get that glucose dot median. So this will return a median middle value. Okay, 117 is the middle value. Okay, so we have seen about how to select a single column, how to select multiple column, how to store it in a new variable. Next, let us see about slicing a series. Okay, as I told you earlier, series is nothing but series is a single column. Okay, what you can do is you can slice a series. Slicing is like cutting it. So we'll check that. We'll select a single column and store it in a new variable. Okay, I'm going to select a single column. What is the column we can select? Okay, select this single column glucose and store it in a variable known as new. Okay, I'll run this. So this is selecting a single column. You can print that and see that new. Now this is a series of Python. So now what I'm going to do is I'm going to slice it. Slicing is like splitting it, right? So I'll try to access with this present in the 0th index. Inside square bracket 0. So what is the output? Okay, 148 is the result we got because it is present in the 0th index. If I give 3, so the value present in the 3rd index, it is like 89. Okay, this is like accessing a string or a list. We are doing right. You will call the name of the variable where we are storing, and we will be passing some values inside the index number. We have sliced our string, right? We have sliced our string, we have sliced our list, we have sliced our tuple. Similarly, you can slice this series, which is a single column. Okay, so you can pass only, like if you want only one index, you can pass that, and if you want from a range, okay, from a starting till a ending index, you can pass that also. You can call, like if I'm giving number 1, it will start from the first index, and if I'm giving 4 as the ending index with the colon, so it will take till 3. We'll do that also. So in new, get from first index till 5th index, so it will get till 4 now, right? We got right 85, 183, 89, 137. This is what this. You can also optionally mention the step of it. Like if I mention 2 here, it will take like 2, 4, 6, 8 in that way. If I mention 4, it will get in that order. Can you 4? Okay, why we are getting this? Because like in the 4th order you cannot get that. If I mention here as 20, so see, it starts from 1, then leave a gap of 4, and then taking 5, then leave a gap of 4, then taking 9. This is what this step does. Okay, if I mention 2 here, usually the step is like 1 default, and you can mention that it is getting 2 steps, right? So this is what the slicing a series is. And if you used to slice a data frame is nothing but multiple columns. Okay, you're using your data set or your data frame, if you are storing multiple columns, you can do that. You can get with the help of index number, with the help of index value, or instead you can slice it. We'll see that to slice a data frame there are 2 things. Okay, you can use 2 tools. One is .loc and another one is .iloc. So in both of the things, see here on the first example, both of the things we are passing the values inside the square bracket only. So what is the difference? Loc means it will locate at index level 5. Okay, so imagine if you are having an index such as, like instead of 0, 1, 2, 3, you are having A, B, C, D and so on. Okay, and what I am wishing to do is I need to get the index which is like D. I need to find the index where D is present, and I need that row alone. So for that, what I can do is I can call the dataset dot locate. So inside square bracket, inside quotation, I'll be passing D, because D is like an integer. Sorry, it is a string, but this 5 is an integer, right? So here both the index number and integers, okay, index are same. It starts from 0. What I am telling is, if it is A, B, C, D, and if I need which is present in that D row, I can use this dot locate. So it will locate that and take that entire row. Or instead, what you can do is you can go on with the index number. iloc is finding the index location. So if I mention, okay, if it is D here and index is 3, obviously, right? So if I mention 3, it will take which is present in that index. Okay, it will locate the index number with index number. This will actually locate the actual index. If it is D, you can find D and get that row. Okay, here in both it is 5, right? If I need to get the which is 3, the index also 3, the index number also 3, so you can go on with both of it, no issue. Similarly, we'll try this first. Dataset, and inside I'll pass 2 here. Sorry, I have to locate it, right? Dot locate 2. Okay, so we'll get what are the values present in that row, okay, for each column. Or instead you can go with iloc. So this will check for the, here both are same, so no issue. But if you are going on finding something else, you can give that here. If you need to find D, you can use this locate. But you cannot give that here because index location is integer only. It starts from 0 and so on. You cannot give D here. You have to pass a numerical value. So what is present in the index number 4, it will start from 0, 1, 2, 3, 4. What is present there, it will print that. This is what the difference between locate and ilocate. And with the help of that, you can slice also. If I need something from the index number D, till z, I can mention that with colon, so it will take from that till that. Or if I need to go on with the index number, I can do this also. I'll show you. Dataset dot index location. I'll pass two values, 3:9, so it will take till 8. Okay, from till 8. So this is how you can use, you can slice a dataset, a data frame also. Okay, now we will see about how to create a new column. Okay, so we have seen about these things. Now we are going to see about how to create a new column. So to create a new column, what you can do is you can call the dataset. We'll be selecting some single column, right? How we will select a single column? We'll just pass the name of inside. So it will select the single column. But instead, if you give something like some column name which is not actually present, okay, a new name, it will consider it as a new column. And you need to assign some value for that, and I am assigning 1 now. We'll do this and see what is happening there. So I'm going to modulate this data set. I'll give a column name known as new column, okay, and I'm setting the value equal to 1. I'll run this and let us use the head function dot head. See here, we are getting a new column known as the name which I am given, and all the values are 1 here. Okay, whatever the value you set, it will like manipulated there. You can also check for the unique values in that column. Column dot value underscore counts. Unique and value underscore counts are similar, but value counts will give you a further option with how many occurrences. Okay, so value 1 is present in 768 rows. Okay, so what you can actually, you can create a new column like this. You can store, you can copy a column also. Okay, you can pass the name here of some other column, so it can be copied there. See, I'm going to call the glucose column here. I'll create it down. So here I'm going to call the glucose column. Glucose. What I'm going to do is I'm going to divide it by 100 and I'm going to store it there. So you can do that. So this column divided by 100, it's storing is in the new column now. Okay. We'll change this and run this. So this will create another column without gap. Dot head. Can you see without gap this column is now the value which is divided by 100, okay? So since I run it, so it is also the same. And see here this 148 divided by 100, 1.48. So you can just like copy and